Hi everyone, welcome to my presentation on prescriptive analytics in airline operation, which is about how the author use arrival time prediction and cost index optimization for short-haul flights to minimize cost. So in this article, the author sought to conduct a prescriptive analysis on airline operations. Their purpose was to use arrival time prediction and cost index optimization for short-haul flights to reduce the cost. Cost index is the ratio of the time-related cost of an airplane operation and the cost of fuel. The article focused on predicting the arrival time for incoming flights at two hub locations. Airlines focus on two aspects in their operations: minimizing costs while ensuring on-time arrivals. With the design model by the researchers, airlines are able to reduce the cost index without any tangible impact on their overall punctuality. The cost index is a tool for optimizing the aircraft speed. They conclude that the optimal cost index level heavily depends on a flight's distance, fuel cost, and delayed cost. Some of the limitations encountered by the authors include the data used was focused on a single airline. The authors also use cost of time per minute for cost index optimization, even though cost of time cannot be calculated per minute for all cost groups. When considering the aircraft performance model, normal flight conditions are assumed, which is rarely the case on most flight conditions. The lack of en route weather conditions has been highlighted as a limitation of the aircraft performance model during the study. They use several machine learning models in their model. The first stage is a linear regression consisting of a subset of highly informative variables, which is included in all other stages of the ensemble. In this stage, they aim to increase overall prediction accuracy of arrival time. The actual total trip time is 127 minutes, but the prediction is 135 minutes. The second stage predictions are made by a gradient boosting machine using a subset of the features not including weather and airport congestion data, which further fine-tunes the initial prediction. The target variable is not actual total trip time, but the residual of the previous stage, which is the same for the following stages. In the third stage, weather information such as weather conditions at arrival and departure airport are used to make a prediction. Stage 4 of the ensemble model combines capacity utilization information for the arrival airport. Final prediction has only 1 minute of discrepancy with the actual one. Significant effort has been made by industry and researchers to ensure the minimization of delays through strategic planning and robust scheduling. The researchers are the first to combine arrival time prediction and dynamic cost index to a prescriptive analytic solution focused on minimizing total cost of flight. Their results show that an ensemble of machine learning algorithm is an adequate tool to predict an aircraft's arrival time. The main case problem can therefore be stated as determining how airline companies can reduce costs through the prediction of arrival time of their aircraft against different factors including weather and delays. Decision variable is the number of cost index should be entered into the system, because cost index influence performance of the plane. Objective of operation is to minimize the cost of operation. The constraints include total trip time, which is from tax out to tax in, arrival time of the plane, scheduled flight time, planned takeoff weight, planned air and ground distance, and the budget of the operation. Uncontrollable parameters include weather data, airport congestion levels, and send the flight information. Total trip time is referred to the combination of flight data, weather forecasts, and airport congestion level lead to the highest arrival time prediction accuracy, and these are referred to the predictable variables. Their final model is based on an example of a gradient boosting machine and a linear regression. The findings include observations that in most cases the airline forecast reacts similarly to changes in certain variables. Short-haul flights are the most insensitive to a change in course of time. For flights with an average distance of 300 nautical meters, the flight time constitutes roughly 72% of total trip time. The increase in attributable time savings is larger with longer flight time. For flights with an average distance of 500 to 600 nautical meters, the flight time constitutes of 77% of the total trip time. Distance and the flight time have a large impact on the amount of minutes that can be saved with an increase in cost index. So this is a reference of my article. Thank you for your time. Thank you.